welcome. This is just a real quick overview of the optics unit. We covered mirrors and lenses and light. So let's get started. Reflection is how we describe the path of light, and it travels in straight lines. And reflection off a flat surface is always going to follow the rule that angle in, which is your incidence, is equal angle out, which is our reflection. And we always will measure the angles from the surface's normal. Remember, we talked about normal when we use forces, and it's always the perpendicular line. And there is the mirror, and the surface normal is perpendicular to that. So incident ray comes in, bounces off to the exit ray or reflected ray, and the two angles have to be the same, just like their definition. A real image forms a real projected image, just a picture of it, and it's always going to converge at a real focal point, and so we can actually get that on a screen, and so it is called real. It can be projected onto a screen because the light is actually passing through a point where everything goes in focus, and it's inverted. A virtual image is just what it sounds like. It's not real because it can't be projected. It's an image because of our eyes' tendency to make straight lines of everything that we see coming at us, and so it's something that is going to be an illusion. And so here you can see a straight mirror, a flat mirror, and the virtual image you see inside of the mirror we did a lab on this, and so hopefully this is pretty much in your brains, but this is a real good way to draw it and to look at it. Okay, so here's you, and you're looking into a mirror. There's the image you, and this is what it appears to be. The mirror only needs to be half as high as you are tall, and you will always be twice as far from your image. Okay, you've seen this, and this just shows you why they write the ambulance backwards on the front of an ambulance, so you can see it in your rearview mirror right, so you'll know what's coming up behind you. And if you haven't tried this, try it in a mirror. It's kind of fun. Curved mirrors are going to be mirrors that aren't going to follow the straight line, but the angle in and the angle out has to be the same. So parabolic mirrors, what we've been talking about, they're going to have a focus, and this shows you how the light rays work. We usually only draw the two rays so that we can see what happens, but you can draw lots of them. A concave mirror is going to curve inward. It caves in, and you can, depending on where you put the object, it will either make a real or a virtual image. So for a real object between the focal point and the mirror, the virtual image is going to form behind the mirror, and the image is upright and larger than the object. And so here it shows you some rays that you can follow that through. If you put the object between the focal point and the center of curvature, we get a real image that's formed outside of the center of curvature, and the image is inverted and it's larger than the object. For a real object close to the mirror but outside the center of the curvature, the real image is formed between the center of curvature and the focal length, but it's inverted and smaller this time. So what size image is formed when a real object is placed at the focal point? And this is the one that we had done on the board a couple times. And it makes sense that nothing is going to be there, because if you follow the lines, in order to go through the points that it needs to go through, you're not going to get those two rays converging. And even in the mirror, if you follow back the reflected rays, they still won't cross, so you don't get an image. Convex mirror are mirrors that curve outwards. It's going to reduce the images and produce virtual images. And And this is what a lot of times you'll see on truck mirrors. This one shows going around a corner. You've seen these in parking garages at hospitals or big malls or something like that. So you've seen them quite a few places. Refraction is when light goes through something and it is going to be bent. So the things it could go through would be like glass, water, your eye, air. The presence of atoms that are closer together than through a vacuum are going to slow down light's progress. And so the interactions are going to cause them to change their direction. The light slowing factor is called the index of refraction. And here are some of the ones that we've been using in class: glass, water, air, and a vacuum. Remember, that's just a ratio of the speed of light in a vacuum to the speed of the light through the material. Okay. Light bends at the point of interface between the refractive indices, and so it bends more the larger the difference in the refractive index. So if it comes in through air or a vacuum and hits liquid, I guess this is glass, it's going to have a greater index of refraction in the glass, and so it's going to cause it to bend towards normal. It slows it down. Convex lenses are going to be thicker in the center than they are on the ends, and so they're bending outwards, I guess. And those are called converging lenses because they bring light together. And they form real images or virtual images depending on the position of the object. And so here's some. You can see the magnifier. A concave lens has thicker edges and thinner in the center, so they've got the two concave sides. It causes the light to diverge, and all images are erect and reduced. So they're upright and reduced. Okay, so just some information for you. Nearsighted, eyeball is too long and the image focuses in front of the retina. And so a concave lens can expand the focal length. Farsighted, the eyeball is too short and so the image is focused behind the retina. So convex lenses shortens the focal length. And so here's more information in case you're interested on how cameras work. I hope this helped. It's kind of review all the concepts, lots of diagrams and the such. So practice, think about it, and go over that review. And we will see you soon. Good luck. Bye.